I hope now it's fine.
Yeah, it is fine.
Okay, thank you. So hello, everybody. And I would like to thank, of course, also the organizers for having me, for giving me the opportunity to discuss with you some of the results from the neutron activation analysis we made in Taganrog. A bit other than I previously announced, I will not only focus on the North Ionian production centers, but like to present all data concerning the Archaic East Greek AMPHORAE. So that means we make chronologically a huge step back into the 7th and 6th century BC. So the ancient settlement of Taganrog was founded by Ionian Greeks in the last quarter of the 7th century BC in the northeast corner of the Sea of Azov. The settlement has long been known in Eastern European archaeology as ancient pottery is continuously washed up in the bay and collected at low waters, as you can imagine from the pictures here below. It was only in the years 2004 to 2010 that the site was systematically investigated as part of a German-Russian project led by Ortwin Dalli of the German Archaeological Institute in Berlin and Pavel Larenok of the Don Archaeological Society in Rostov-on-Don. The trenches were laid out at the foot of a high terrace next to the beach, and it is safe to assume that the center of the ancient settlement was also on this plateau. So you see here the plateau, and here's the terrace, and at the foot, the trenches. So our excavations took place only on the periphery of the settlement, and therefore the fine spectrum provides just a small amount of pottery. This assemblage is supplemented by finds from the beach, and the overview here in the pie chart already highlights the importance of the transport amphorae you see in the blue pie piece. In total, these are 1,731 fragments of amphorae, which I examined, and this accounts for almost 53% of all pottery fragments. Considering the chronological distribution over the phases from the 7th to the 3rd century BC, it is noticeable that the vast majority of the ceramics originate from the older archaic layers of the 7th and 6th century. And already in the layers of the 5th century, the number of finds decreased significantly. The investigation of the pottery is based on macroscopically defined fabric groups. Since the amount of fragments is very small, I analyzed all shards, that means also the wall fragments. And the quantification here gives just general impressions and does not show the absolute numbers of individual vessels. In order then to be able to connect these fabric descriptions with production regions, I compared the preserved profiles with established typologies and published fabric descriptions in a first step. And to test this method, in the second step, we started an extensive archaeometric program together with Professor Dr. Hans Mommsen of the Helmholtz Institute für Strahlen- und Kernphysik of the University of Bonn. And I would like to express my deepest gratitude to him and also to the German Archaeological Institute for the generous funding of the analysis. And if you are interested, you can find the raw data on the homepages cited here on the slide. For more than 30 years, Hans Mommsen has regularly carried out chemical analysis of ceramics using the NAA, so this method has been proven to be successful. On the basis of about 30 concentration values of mainly minor and trace elements, distinct element patterns can be determined that form a characteristic chemical fingerprint. More than 12,000 samples from excavations all around the Mediterranean and the Black Sea have been examined by means of the NAA in Bonn and provides us a huge database for the determination of chemical provenance groups. In Taganrog, we mainly pursued three aims that also guided the sample selection. The first was the control of already well-known classes and established typologies such as bird balls or Kian amphorae. The second was to determine or to specify the provenance of unknown profiles or unlocalized types. And the third aim was to check the macroscopically defined fabric groups and the applied method. In total, 203 sherds were sampled and 108 pieces belong to AMPHORAE, and they are spread over 21 different chemical patterns. The majority of the AMPHORAE can be dated to the Archaic period, and I will therefore concentrate now on the results concerning the Archaic East Greek AMPHORAE and what they can contribute to our knowledge of production centers of this period. Concerning the South Ionian AMPHORAE, there is little more to add to the current state of knowledge. The main body of the sampled profiles of this type fit well with the Milesian city groups, Miletus A and Miletus D, which come from the Kalabak workshops. We know that also other centers, such as Ephesus, were involved in the production of these AMPHORAE. There is another rim here at the bottom left with the number 131, and this attests a further center, which is by now unlocated. It's from the group unlocated number 4, but was in all likelihood also situated in South Ionia. Other fragments of that group are delicate cups with eroded rims of a type for which analyses of Pierre Dupont point to a Samian production, and you see another such cup here next to the rim. Interesting is also the rim number 194. Compared with the canonical rims of Milesian type AMPHORAE, this is only weakly pronounced. What it remarkably resembles the rim number 13, which falls into the chemical group Troas T of the so-called Hellespont workshops. The chemical patterns of these groups are clearly distinguished from others and can be linked to the region of the Hellespont by samples of rock clay as reference material. So far, only tableware in these groups is known, and the vessels copy South Ionian, especially Milesian styles in terms of decoration and shapes. And therefore, these workshops at the Hellespont were interpreted by Richard Cousin-Mentier and Michael Kerschner as foundations of craftsmen from South Ionia as kind of migrant workshops. The both rims here from Taganrog show now that the similarities between the Mayandros Valley and the Hellespont are not only limited to the production of tableware, but also affected the transport AMPHORAE. The well-defined group Samos J can be linked with the island of Samos. The material from Taganrog bears 10 samples, which is surprisingly high, compared with the low number of finds which typologically fit Samos, not only in Taganrog, but in the Black Sea at all. We sampled 4 bases of these AMPHORAE, of which 3 fall into the group Samos J, and 1 is a chemical single you see here on the right. Microscopically, this fragment does not differ from the others in terms of fabric and shape, and probably derived from another still unknown workshop. I now turn to the production of North Ionia, where Chios was one of the most active centers, as has recently become clear thanks to the excavations of Musacadiolo in Chios. Kiln wasters of transport AMPHORAE were found, which were analyzed by Michael Kerschner and Hans Mommsen, also by means of NAA. The results revealed the long-known chemical pattern B and thus confirmed its localization in Chios. Among the material from Taganrog, 4 AMPHORAE rims show the Chios B pattern. 3 of these rims have a bulging profile indicating similarities to the Clazomenian type AMPHORAE. And they found also parallels among the so-called AMPHORAE with profile toe, or the yesterday already highly debated Proto-Thasian AMPHORAE, for which Pierre Dupont and Vasilika Lungo already suggested North Ionian or Thracian production centers based on XRF analysis. The kiln wasters found in Chios belong to the type with profile toe, and they are well comparable to the Taganrog finds. The AMPHORAE from Chios will soon be published in detail, and I am grateful to Michael Kerschner for sharing his information with me in advance. Hence, Chios can now securely be added to the list of the centers involved in the production of this widespread class of AMPHORAE. A different type is represented by the rim number 109. This is a quite massive high band rim with a weak profile at the neck and a handle attached directly beneath the rim. It was found on the beach of Taganrog, hence cannot be dated by stratigraphy. The appearance of this completely different profile could therefore have chronological reasons. It is well comparable to a Hellenistic amphora type, which can be assigned, for example, to Erythrae, with the results of the sample of Taganrog 109, we can now trace also Teos as a producer of this type. The island of Chios is represented by 8 samples in Taganrog with the chemical pattern Chios A. They also typologically belong to the Chian production and show the characteristic thick white engobe and band decoration. However, some of these fragments, such as the rim Taganrog 175, so this one here, combine features of both Chian and Clazomenian typology. The rim shows also the white thick engobe, but the profile perfectly fits with Z-skin Clazomenian group number 4. The best parallel is found among the Taganrog finds themselves, but this rim provides the chemical pattern Clazomenai G, which originates directly in Clazomenai. This pattern Clazomenai G is well represented in Taganrog and exhibits several rims of Z-skin's Clazomenian groups 1 to 4. And once again, there are examples with close similarities to the Chian early series. Clazomenai is also attested by another chemical pattern, which is called Clazomenai A and proved by 2 wasters, yet unpublished. Chemically, it is very similar to the Clazomenai G pattern and bears also characteristic Clazomenian type profiles. However, another 4 samples, similar in their fabric to the previous ones and with Clazomenian type profiles, are chemically singles, thus indicating further workshops in the region. As pointed out by Pierre Dupont, Yusuf Z-skin, and others in North Ionia, we are dealing with a very densely woven network of workshops that influenced each other. Especially archaeologists working with the fragmented materials should be cautious by attributing vessels to a specific sender without a chromatic analysis. Interesting results appeared for the Aeolian region with the type of lesbian gray and red-fired amphorae. They belong to 3 as yet unlocalized groups that are chemically well separated from each other, indicating different production sites. The group numbers unlocated 3 and unlocated 35 contain only gray-fired fragments and only 1 profile you see here above. This is a short projecting rim on a slightly funnel-shaped neck, but without the ridge that is so characteristic for the lesbian amphorae. The group number unlocated 21 included both gray-fired as well as re-oxidized red-fired pieces. The gray-fired series is made up of 3 handles with round cross-section, and the red-fired amphorae are represented by 2 rims. It is noticeable that these rims typologically correspond more to the gray series. They also lack the typical ridge at the neck, and the projecting rim flattened on top with funnel-shaped neck is, according to Julian Bizescu, characteristic for his type 3 of the gray-fired vessels, but untypical for the red-fired amphorae, for which he states rounded rim as common. Given the same chemical pattern for the gray as well as for the red-fired amphorae, the typological adaptations are perhaps no coincidence. It was probably one production sender that made the same shapes using different techniques. The results of the unlocated 21 group are significant because they prove a common provenance of the gray and red-fired amphorae. It has long been assumed, of course, that these 2 series were both produced on Lesbos due to similar fabrics, morphological characteristics, and the same distribution patterns of the vessels. However, the re-oxidized amphorae have scarcely been analyzed so far, and key arguments for the localization in a specific sender have been lacking. The results of these Aeolian groups are also interesting with regard to the quite numerous chemical singles among the typological lesbian amphorae. As in the case of the Clazomenian type amphorae, we still have to expect a large number of further production sites for these amphorae. As a surprise came the result for a massive handle, which I expected to be of Cohen provenance due to its fabric, but it fits the chemical group Iolus G, which is supposed to be located in Cumae. We have no chronological evidence for the handle, but it is interesting because it is the first known amphorae from these workshops, which are otherwise famous for the London Dinas group, but also for simpler tableware such as rosette bowls. You see an example here next to the handle. So to come to a short conclusion, the NAA from Taganrog exhibit new insights into the production of Archaic East Greek amphorae. The identification of two different amphorae types with teos is striking. It is also crucial that the long since expected connections of the lesbian gray and red-fired containers have now definite validity. And furthermore, the deeply entangled regionalism of southern and northern Ionian workshops can be observed in more detail. And I thank you for your attention.